Climate Action Microbit. So I first began by building my seed planter, and I got the code, Microbit, and both motors working, and I began to build my rough prototype and started my research, but then I realized I was more passionate in one of the other areas. So I decided to target advanced agriculture, and from my research, I discovered that in Canada, we can attribute 10% of our carbon emissions to agriculture. Before 2017, Canada produced 31.95 billion tons of CO2 to date. Healthy soil actually retains a large amount of CO2 and prevents it from entering the atmosphere, but unfortunately, agriculture and the use of fertilizers damages the soil. When fertilizers are overused, the soil gets saturated and damaged, causing it to release some of the CO2 that it was holding, and then can no longer retain as much as healthy soil once could. If we put an effort into restoring our soil health, then it has the possibility to absorb 5 billion tons of CO2 annually. However, solutions to this are expensive and time-consuming, and hardworking farmers don't have the time or resources. So targeting soil health through advanced agriculture is a great way to reduce carbon emissions. So I decided to dedicate my project to this cause. So how do we target this? My idea was to incorporate an automatic fertilizer pump into my microbit that directly fertilizes the plants in small, consistent quantities, rather than large amounts all at once, to prevent shocking the soil and without adding more work for the farmers. So here you can see my initial work for the water pump. I built the water pump water sensor in a basic pop bottle prototype, and there's my code. And here are my iterations. So I added a second pump for fertilizer, and I programmed it to pump on a timer, faster here than in real situations, but that's just for demonstration purposes, and it can be changed. I incorporated a portable power element, and I made a prototype from cups and cardboard. And the reason I use cups and not plant with soil is that I could show the watercolor in my next demonstration. So here you can see my finished prototype, and you can see that I dyed one source of water green to represent the fertilizer. You can see how the water is being pumped into the sensor is covered, and every 5 seconds or so, a small amount of green water or fertilizer is being pumped in. If this were to be in action, the pump would be a much slower timer, but I did this so I could show the function of my robot. So what's next for this project? Healthy soil has a pH of around 6.5 to 7.5, and fertilizer causes the soil to become more acidic. Users will have the option to select how long they want the fertilizer to pump for, and depending on the size and species of their plant. But I also want to incorporate another sensor which senses the pH level of the soil. If the fertilizer starts to overwhelm the soil, it will become too acidic, and the new sensor will sense the levels and turn off the fertilizer pump until pH levels resume. This will prevent soil acidification, which is a large contributing factor in soil losing its ability to store CO2. Unfortunately, from my research, I couldn't find a way to modify the microbit sensor to sense anything other than a wetness level, so if I had more time, I'd pursue this iteration. So here's my works cited list, and thank you for listening.